Hello everyone and welcome to Third Days of Java. It's day 21 now and today we'll continue our discussion on the collection framework in Java. In this video, we'll discuss the queue and set interface in Java along with their implementations. So let's begin. Looking back at the Java's collection framework hierarchy, we can see both queue and set interface also implement the collection interface and have various implementations and some interfaces extending them like deque and sorted set. Let's now look at each one of them individually. The queue interface follows the first in first out principle, that is FIFO, meaning the element that was added first will be removed first. In simple words, imagine a line of people waiting for a bus. The person at the front of the line, the one closest to the bus stop, is the first one to get on the bus when it arrives. PriorityQueue is an implementation of the queue interface that provides a priority-based ordering of elements. Elements are ordered based on their natural ordering if they implement the comparable interface or by a comparator provided at queue construction time. In the example shown, we have created a priority queue of integers, but since we have not passed any comparator in its constructor, it orders the element in ascending order based on their values. The priority queue is implemented using a priority heap, which is a binary heap data structure. A binary heap is a complete binary tree where each node satisfies the heap property, meaning the parent node's value is either greater than or equal to or less than or equal to the value of its children. The deque interface in Java represents a double-ended queue, which allows insertion and removal of elements from both ends of the queue. ArrayDeque in Java is a resizable array implementation of the deque interface. It does not have the capacity restriction of a regular array and grows dynamically as elements are added. You can use the add method to add elements at the end or use add first to add them in the front. Set interface represents a collection of elements with no duplicate elements. It does not maintain the insertion order of elements. A HashSet is an implementation of set interface, which uses a hash table internally, which is a data structure that stores element in an array, where each element is indexed by a hash code derived from the element's key. When you add an element to a hash set, Java computes the hash code of the element using the hashcode method of the object. The hash code is then used to determine the index, that is bucket, where the element will be stored in the array. Since multiple elements may have the same hash code, which is known as hashcode collision, HashSet uses a technique called chaining to handle collisions. Each bucket in the array can store multiple elements, typically in the form of a linked list or balanced tree. As you can see in the example shown below, we are first inputting a value of 1 into the hash set. First, the value is used in a hashing function, which creates an index for the bucket. So for input 1, the index is 1. So we'll add that. Now for input 2, we are given the value of 3. After putting it through a hash function, the index value comes out as 3, which is the bucket index 3. So we add that. Now suppose we input another value into it, that is 10. Then after passing it through the hash function, let's just say it gave out the index value as 3. But since we already have a value at index 3, that was input 2, we would chain together the input 3 and input 2 as shown below in a linked list structure. A linked hash set is another implementation of the set interface that extends HashSet and maintains a doubly linked list running through all of its entries. It combines the feature of a hash table and a linked list, providing the ordering of elements based on the order in which they were inserted. It is implemented similar to HashSet in memory. The only difference, however, is that it uses a doubly linked list in implementing the hash table which maintains the insertion order of elements. TreeSet in Java is an implementation of the sorted set interface that uses a self-balancing binary search tree, specifically a red-black tree, to store its elements. Unlike HashSet, which does not guarantee any specific order of elements, TreeSet maintains its element in sorted order. Now let's first start by creating a priority queue. So for that, we'll type in queue, that is the name of the interface. Then for the data type, we'll use integer. Then the name of the object, we'll type in priority queue equal to new priority queue. Now one thing to note here is that we are using the integer data type instead of int. This happening because with queue and set interface, we can't use the primitive data types. If you want to use the primitive data types, we need to use their wrapper classes. So integer here is nothing but a wrapper class for int data type. So if I remove this and replace it with int, you can see it's giving me back an error that says type argument cannot be of primitive data type. Now let's change it back. Now to add elements to this priority queue, we'll simply type in PriorityQueue.offer and then the value that we want to enter. So we'll type in 4. We'll copy this and add some more values. Now to output the value at the front of the queue, we'll simply type in sout and then PriorityQueue.peak. Now if I run this program, you can see it gave me back the value 1. Now why is this happening? Because we entered 4 first, and we already know that a queue follows the first in first out approach. So here we are using a priority queue which stores element based on their priority. And since we are storing integer data types and we are not giving it any comparator in the constructor, it's maintaining those values in an ascending order. That is why 1 is coming back first. If I remove the 1 by typing in PriorityQueue dot remove and then run this program, you can see it gave me back the last element that we entered, that is 2. If you want to change the ordering of the elements in this priority queue, we can simply type in Comparator dot reverse order here. And then if I run this program, you can see it gave me back 4 because it changed the ordering of the elements into a descending order from ascending order. Now let's clean this up and see how an ArrayDeque works. So for declaring an ArrayDeque, we'll type in deque, then the name of the data type. So again we'll use the wrapper class, then ArrayDeque equal to new ArrayDeque. Now an ArrayDeque can be used to add elements to it from the front and from the end. To add elements at the end, we can simply type in ArrayDeque.add and then give it a value of, let's just say, 1. And let's copy this. Let's say 4, 5, and 2. Now, if I traverse this ArrayDeque using a for each loop, I'll simply type in var temp and then ArrayDeque and will output everything. So I'll simply output temp. Now if I run this program, you can see it's maintaining the order of the elements that we entered, that is 1, 4, 5 and 2. If I remove an element from this by typing in ArrayDeque.pop and then run this program, you can see it removed the first element from the list, that is 1. Now with a double-ended queue, we can remove or add elements to the front or the end. So if I want to add an element to the front of the queue, I'll simply pass in ArrayDeque.add first. Then I can give it a value of 1000. Now if I run this program, you can see it added the element at the front of the queue. I can also remove the elements from the back of the queue by typing in ArrayDeque.remove last and then run this program, which would remove the 2, that is the last element of the queue. So this is how the double-ended queue works in Java. Now let's clear this up. And create a hash set. So for that, we'll type in set, that is the name of the interface, then integer, then we'll call this set in lowercase, the new hash set. Now the main property with using a set is that you can't use duplicate values. So I can add elements to the set by simply typing in set.add. I'll type in 1, then 3, 5. And I can create a for each loop and simply type in var temp, then set, then sout the temp. Now if I run this program, you can see it works without any hiccup. But if I add another element into this, that is set.add, and then pass it 1, which is already added into the set, and run this program, it won't throw an error or exception, but it won't add the duplicate value. Now we can change this implementation from using a hash set to using a linked hash set, and then run this program again, and it still works fine. And I can also change this linked hash set to a TreeSet, and run this program, and it still works fine. So from a surface level, they all look and feel same. However, in memory implementation, they are implemented differently. A hash set uses a hash table, whereas a linked hash set uses a hash table with linked list, as we have already mentioned in the slides. And the tree set uses a red-black binary tree. So the main difference between a hash set, linked hash set, and a tree set is that a hash set doesn't keep the insertion order of the elements, whereas a linked hash set does. And the tree set maintains the elements in a sorted manner. So if I add another element into this, and let's call this 2. Now if I run this program, you can see it gave me back the output 1, 2, 3, 5. But if I change this to a linked hash set and then run this program, it gave me back the value 1, 3, 5, 2. That is the insertion order. And if I change this linked hash set to a hash set and then run this program, you can see it's not maintaining the insertion order. So this is the basic overview of collection framework in Java. Now there are various other classes and interface to this collection framework that are beyond the scope of this course. But if you want to learn about them, you can simply check out all of them on the Oracle's official website. As always, we'll end this video with a quote that says, "Fate leads the willing and drags along the reluctant." Thank you for watching and have a great day.